let's get started with our material. As I promised, stuff isn't all going to be podcasts and PDF lectures and scrolling through. There is going to be actual content on video for guys to use. So first, we're going to take a look at the ideas of induction and deduction, and really general idea of inductive and deductive reasoning. Imagine a lot of you guys might have an idea of what induction and deduction are, maybe from hearing that word here and there in pop culture, but hearing those words. But your ideas might be a little bit off base on. I'm going to start off with a quick definition of inductive reasoning. So, working with inductive reasoning, what we're doing is take some information that we have. We are looking to take some specific evidence that we're working from. We're trying to build a more general conclusion. The definition of induction, to say it, is the process of drawing general conclusions from specific evidence. So if you want to think about it this way, induction is a process by which we take specific ideas and draw from them general conclusions. And I will say before I get going too far, one thing that everyone in my classes learn, no matter how much math they learn, is that my handwriting is not the best. I work with it as much as I can, and hopefully you guys will be able to get what you need, but for the most part, there's a reason why I try to type as much as possible for my classes, because I know it can be a bit of a struggle, and that's not something I need you guys to do too much. Anyway, the idea here is we take small pieces, we see if we can build them up, get something that has a bit more breadth and general strength, I guess you could say. So when we're working with this idea, we have something else to it. Concept of conjectures and hypotheses. Now, you've probably heard at least one of these terms before, and for our purposes, they're somewhat close to being interchangeable. Or what we're looking at with a conjecture or a hypothesis isn't anything too special. It's really just our educated guesses. And specifically, they're the educated guesses that we get using inductive reasoning, induction. They're the general conclusions that we draw from our specific evidence that we sort of build our way up to. So say, for example, if you get up every morning at about 8 a.m. for a week, and in that week you always are able to make it to class on time, you could call that your specific evidence, your specific ideas, that time getting up every day. And your general conclusion from that, your conjecture, might be that if I get up at 8 a.m. every day, I'm going to make it to school on time. And that might be a good idea to think of. That might be an accurate idea. Another thing we have to think about here is not just what we have with these ideas, these conclusions we can draw, but whether or not they're actually valid, because sometimes things don't fall into a nice pattern the way that we see them. The idea of induction really is pattern recognition. It's seeing that if thing A happens, then thing B happens, then thing D happens, or then thing C happens, we should expect thing D to happen. Excuse me. That's not always guaranteed. Let's say you get up out of bed every day at 8 a.m. and you have no problem, but one day you get up out of bed when you're supposed to, and you get in your car and you drive and there's an accident, and suddenly you can't make it. And that idea that if you leave at 8 a.m. and you get to school, then you'll get to school on time, no longer really can be said to hold water, because it didn't hold once. In math, the idea of something being true is a very sticky concept. It's not easy to prove that something's true, but it's very easy to show that something's false because we only need something to be wrong once to say that in the mathematical sense, in the sense of this kind of logical reasoning, it's not actually true. When we're doing that, we're using a method, we're using an idea called a counterexample. For counterexamples are situations where what we think is not true, where what we expect doesn't happen. They're situations, single cases really, you don't need that many, where the conjecture isn't true. In other words, where the conjecture is false. So for that example, the idea of getting to school on time, the one case where it didn't happen is your counterexample. It only needs to not happen once to be able to say, or more appropriately, to not be able to say that it's true.